All right, looking at another example, it says an online bookseller has a new book in print. The company estimates that if the book is priced at $15, they're going to sell 800 copies in one day, or per day, I should say. The book is priced at $20, then they're going to sell 550 copies of the book per day. So it says identify the order pairs given in the problem. And it might not seem like they're order pairs, but let's take a look at our graph right here. Notice our x-axis is the price. We have the price. Our y-axis is the copies. We have the copies. So when it tells us what is the ordered pair, we can say our x value, our price, $15, and our number of copies, 800. So our input is 15, our output is 800. If we price the books at $15, then we're going to sell 800. Likewise, if we price the books at $20, our output will be 550 copies sold. So here we go, right? We have a couple points here. And it says assume that the relationship between the number of books sold and the price is linear. In other words, it's a straight line. So let's plot these 2 points. So the first thing I want you to notice is this crazy looking thing right here. Okay, this is called a bar break. And I want you to think of a bar break as we just like squished the graph, right? So notice our scale here, 15 to 16 to 17 to 18 to 19. That's all pretty equal. But there's a whole lot of what happens between 0 and 15. Well, in this case, actually, there's not. There's a whole lot of numbers there. And if we did this graph and we wanted to go by ones, this would be a really big graph with nothing happening from 0 to 15. So what we do is we like kind of think of it as squishing the graph together and putting 1 through 15, right, in that little section. Later on, when you do statistical work, you're going to realize that that can like skew the data, which means make it look a little bit different. But for right now, it's a helpful tool for us when we want to really focus on just a certain set of numbers, okay? And we can't just skip them, okay? Got to give respect to all the numbers between 0 and 15. That's why I put that bar break there. Okay, so I'm going to plot 15 and 800. And 20 and 550. So if I look carefully here, 400, 450, 500, 550. And now I'm going to take my straight edge and I'm going to draw a line through these points. Okay. All right. So now the next one says, what is the rate of change? Well, we can figure out how much you're going down and going over, but again, they're going by 50s, so we have to be careful. So remember, rate of change or slope. Why don't we just find the slope between these 2 points? Remember, this is the x value, this is the y, this is the x, this is the y. This is our first point, and this is our second point, or vice versa. Because our slope formula is the difference in our y's, y sub 2 minus y sub 1, over the difference in our x's, x sub 2 minus x sub 1. So remember, rate of change and slope, we can use our slope formula to figure out what the rate of change is. So I'll start plugging things in. y2 is 550 minus y1, which is 800, over x2, which is 20, minus x1. Sorry, that's a 1 there. Is 15. Okay, and if we figure this out, we get negative 250 divided by 5, which is a negative 5. What is a negative 5? Well, remember, we're talking about our copies per price. Okay, so our copies is our y, our price is our x. So if we have negative 5 or negative 5 or 1, it means we're going, or the number of copies goes down. I'm sorry, this is negative 50 here. Again, my bad. Down 50 copies. Try to spell things right too. Down 50 copies for every price increase. So when you go from 15 to 16 to 17, Okay, every unit price increase, it's going to go down 50 copies. Okay, now at some point, this is only for this section. All right, at some point, you're going down enough, it doesn't matter what you price it at. Okay, so based on the graph, if the company prices the book at $18, how many copies of the book will they expect to sell? All right, this isn't a perfect science, but what they think. So here is 18. Okay, if we do a better job than what I just did, okay, if we follow this line up from 18, so that's the number of copies, or I'm sorry, that's the cost, and we take it over, we could say it's approximately equal to 650 copies. It hits the line at that point. Now the next one says, based on the graph, approximately what price should the company charge in order to sell 700 copies? So if we want to sell 700 copies, go to your graph. Here's 700, right? So 700 is going to, excuse me, hit the graph right there, which means if they want to sell 700 copies per day, they should charge $17. All right, so just to kind of sum things up right here, a linear function that models a situation is given by the equation y equals ax plus b, a plus bx. Again, y equals mx plus b. But we're talking about rate of change and initial value, okay? We can use that to graph, or when we know two or more ordered pairs, we can also use that to graph the line. So this is just different ways we can represent that line, which can give us some good information about the problem we're working on.